Hello and welcome to CodeRage 6. My name is Bojan Mitov, the president of Mitov Software, and in this session I will demonstrate how we can take existing VCL controls and make them available in the FireMonkey framework. The reason we will cover specifically controls is that any non-visual VCL component is immediately available in FireMonkey and no additional work is needed. The obvious question is, why should you support both platforms? The answer is that while FireMonkey is the future of the cross-platform development, FireMonkey is still in version 1.0 and needs to mature before becoming as powerful as VCL is. VCL, on the other hand, is a very mature platform. However, VCL is Windows only and only limited future development is planned for it. Supporting both platforms gives you the best of both worlds. Before we start converting controls from VCL to FireMonkey, let's compare the two frameworks and see what we need to be aware of. First of all, VCL and FireMonkey do have a lot of similarities. The controls in both frameworks inherit from T-component. The controls in both have paint method where we should do our painting. That is under the assumption, of course, that your original VCL control was inherited from T-custom control. Both frameworks have T-canvas, although, as we will see a little bit later, the two T-canvases do have differences. Both frameworks have T-bitmap, although the class differs a bit. They both have a lot of similar methods, such as mouse up, mouse down, set bounds, and so on and so forth. They have a lot of similar or downright identical properties, such as color, visible, tap order. There are some differences, of course. The color in VCL is usually of type T color, while in FireMonkey usually it is T alpha color. Now let's focus on the differences. The first and simple difference is that the two frameworks use different units. In XE2, the framework-specific units have a framework-specific prefix. Units specific to VCL have the prefix of VCL, and units specific to FireMonkey have the prefix of FMX. There are also shared units, such as the new in XE2 UI types, which have the prefix of system. In VCL, we usually inherit our controls from T-custom control. In FireMonkey, the equivalent is directly the T-control class. The coordinate system in VCL uses integers. The FireMonkey uses single. The invalidate method is not available in a FireMonkey, and we have to use methods such as repaint to force repainting. There are also some differences in namings, such as focused in VCL is called isFocused in FireMonkey. Some functionality which was implemented with messages in VCL, such as CM visible changed, now is implemented as set visible virtual function in FireMonkey, which obviously makes the development in FireMonkey easier. The single mouse wheel method in VCL is replaced by two separated do mouse wheel up and do mouse wheel down methods in FireMonkey. The T-canvas implementations and functionality of VCL and FireMonkey are very different. The same applies for T-bitmap. The two T-bitmaps do have a fair number of differences. For this session, we should pay more attention to the differences between the two T-canvas implementations. The first difference is that the VCL T-canvas uses integer coordinate system, the FireMonkey uses single or floating point coordinate system. The VCL T-Canvas uses T-color type for colors. The FireMonkey uses T-alpha color. The drawing functions such as ellipse, rectangle, and so on in VCL draw both with pen and brush, while in FireMonkey the pen and brush equivalent drawing is implemented with two distinct functions. As example, ellipse in VCL is roughly equivalent to calling both fill ellipse and draw ellipse. The brush property in VCL is roughly equivalent to the fill property in FireMonkey. The pen property in VCL is roughly equivalent to the stroke property in FireMonkey. T-brush and T-pen class types in VCL are roughly equivalent to the T-brush type in FireMonkey. We will demonstrate the process with a simple TSmiley component which I have written for this purpose. Here is our TSmiley component. It obviously has features as eyes, nose, mouth, and obviously the whole face. If we run it, you can see that by clicking over the component, we do have a simple eye animation. Here is the source code for our TSmiley component. The reason I have named it this way is because we will make this component available both for VCL and FireMonkey, so it will be a dual compile component. The code is very straightforward. First we have three fields which we will use for our properties for different types of color. The setter functions. We override the mouse down and mouse up member functions. We also override the paint function where we will implement our painting. We have constructor, the three properties for different colors. The constructor only contains initialization for the fields. Where the real code goes is our paint function. First, we'll calculate fill sizes and positions for various elements on the face. Then we'll draw the face. We'll draw the eyes. We'll draw the nose. And finally, we'll write a little bit of code to draw the smile. We have straightforward implementation of our setters. Each time when the field is assigned, we also invalidate the control, so it will be refreshed. For the mouse down and mouse up, we have very simple code where we assign a flag and then we invalidate the painting. Based on that flag, we'll have different vertical size for the eyes. Now it's time to start changing the component so it will compile in FireMonkey as well as in VCL. The first step is, since we will need some conditional compilation, we'll need to have a mechanism to distinguish whether or not we're compiling in VCL or FireMonkey. Hopefully, such a mechanism is very easy to implement. As you probably have noticed, most of the FireMonkey units start with a prefix of FMX followed by dot. I have created an FMX demo package. In this demo package, I have added an fmx.dollsmiley.pass unit. This unit is very short and simple. All it contains is a conditional definition, and immediately after that it will include our existing doll smiley. The first thing we need to do is to make sure that if the conditional variable is defined, we will skip the unit name. There are some Delphi library units which are VCL specific. We should avoid using them in FireMonkey, especially when they're not necessary. Here we have two of those units, controls and graphics. The same definitions that are in those two units are available in FMX.types. So in case of FMX, we will need to include that unit. This if-def will make sure that we use the correct units depending on the compilation. FireMonkey supports both tcolor as well as the new type tAlphaColor. However, tAlphaColor is the typical color used in FireMonkey controls. It will be really beneficial if our TSmiley works as any other FireMonkey control. For that purpose, we will add some conditional color definitions. This step is not necessary, but definitely will make TSmiley much more FireMonkey friendly. In this case, we will define a new type called tDualColor, which in case of FireMonkey maps in tAlphaColor, in case of VCL maps in tcolor. Now we will replace tcolor everywhere with tDualColor. In our case, our TSmiley in VCL was inherited from tCustomControl. There is no tCustomControl in FireMonkey, so instead in FireMonkey we'll inherit from tControl. The next problem we face is that mouse down and mouse up in FireMonkey and VCL differ a little bit. In FireMonkey, the X and Y coordinates are of type single, while in VCL they are integer. For that purpose, and since we want to reuse some of the code, we will use a small trick. We will declare mouse down helper function and mouse up helper function, both of them accepting the same type as in VCL, and then we will declare mouse up and mouse down as it is declared in FireMonkey in the case we are compiling for FireMonkey. The next problem we face is that invalidate is not available in FireMonkey, so we will have to implement a workaround. We will add a conditional invalidate, which we can use from our setters as well as mouse up and down functions. Now it's time to start modifying our implementations. We'll start by adding the invalidate conditional function. All it needs to call is repaint. Next, we'll make the necessary changes for mouse up and mouse down. Since mouse up and mouse down may contain bigger amount of code than the one shown here, we will use a special trick allowing us to preserve the code as much as possible. In this case, whenever we compile for FireMonkey, we will round our coordinates and we will call our helper function. The helper function, since it has the same signature as our VCL mouse down function, will be able to use exactly the same code. We'll do the same for our mouse up. Now that we have finished with the simple parts, the real challenge lays ahead. Both VCL and FireMonkey contain T-canvas. They have a lot of similarities, however, they also have a huge number of differences. As example, VCL contains T-brush and T-pen. On the other hand, FireMonkey contains fill and stroke that have similar functionality. The drawing functions in FireMonkey use floating point coordinates, where in VCL they use integer coordinates. The parameters that the drawing functions take in the two platforms differ substantially. The question is how to preserve most of our painting code while making it available in FireMonkey. I will show you a trick that allows minimal changes in your code while at the same time making it to compile in both platforms. We will implement our own T-canvas type of class that mimics the behavior of the VCL canvas, and we will use it in FireMonkey. Here I already have written a very simple version of this class, which contains only the functions used inside TSmiley. You can start using this class and add the necessary functions for your own controls, or you can use the same idea and implement such class from scratch. In this case, I have called it TDualCanvas. It has ellipse and angle arc, which are the only two functions used in this project. Obviously, in more complex controls, you will need to implement more functions. It also has only brush property, since that is the only property I need to set in my code. For this property, I have implemented my own brush class, which is extremely simple. It simply has T-canvas field. In the set color, we'll set the fill color, which is the equivalent of setting the color of the brush in VCL. And the getter just gets the color of the fill. Since we are working with alpha colors, my brush will take alpha color. Our TDualCanvas will set initial settings for the stroke to mimic the functionality of the T-canvas in VCL. It will make instance of T-brush, and the destructor will destroy the T-brush. Our ellipse function will both call drawEllipse and fillEllipse to mimic the way the ellipse function in VCL T-canvas operates. The last parameter in FireMonkey indicates how transparent the drawing will be. 1 means that the drawing will not be transparent. 0 means full transparency. In angle arc, we'll call drawArc, and we will do simple recalculation of the angles, since the two frameworks use different coordinate system. To use T-canvas in FireMonkey, all we need to do is add the FMX.types unit. In order to use the FMX.graphics, when we compile for FireMonkey, we need to add it to the uses section of TSmiley. Next, we will make sure that dual canvas is also available as type when we compile for VCL. We're almost ready to get our code to compile for FireMonkey, but we face a small problem. In Paint, we're directly working with canvas. We have instead to work with our dual canvas. Luckily, we can embed functions inside our Paint function. So now I will add embedded function that has a parameter of type tDualCanvas, and we'll move the painting code inside this function. Now, all we need to do is replace canvas with a canvas. We're almost done, however, few small challenges lay ahead. Unfortunately, width and height in VCL are integer, and in FireMonkey they are floating point. To solve that problem, we'll add two integer variables and we'll assign them different way depending which platform we're compiling for. Then we'll change our code to use those new variables. Next, we'll remove some VCL-specific code which has been added into the component to work around some design issues when using the VCL's tCanvas angle arc. The problem is that it always draws line from the previous position of the drawing cursor to the beginning of the arc. We do not want to see that in our TSmiley, so for this purpose I have added a little bit of code for drawing with clear pen. This code is not necessary since such problem does not exist in FireMonkey. The last thing we need to do in this function is in FireMonkey to create instance of our helper tCanvas. First, we need to declare variable for it. Next, we will have to call our internal function. In case of FireMonkey, we'll create instance of our helper class, call the embedded function, then destroy the instance of the helper class. In case of VCL, we will just call the internal function with tCanvas, since tDualCanvas is mapped into tCanvas. TAlphaColor in RAD-Studio XE2 is defined into System UI types. In order to use it, we need to add that unit. We also will need to replace in our code the constants for the different colors. Now it's time to compile and install our component. Our component is ready to be used in FireMonkey. To test our component, I have added a FireMonkey project to my project group. You can see that our FireMonkey component is available on the tool palette. I can drop it in the FireMonkey application. I can compile and run it. Here is our FireMonkey application with the TSmiley component inside. Our component is a first-class citizen of the FireMonkey framework. It uses the same color editors as any other FireMonkey component. We can even add effects and animations to it. I will let you play with those functionalities yourself. Try yourself to convert as many components as you can into FireMonkey because it is fairly easy and a lot of fun. Finally, we will confirm that the component still compiles and can be used in VCL. We will rebuild the VCL unit. And we will reopen the VCL project. We can run the component in our VCL project. And we can run it in our FireMonkey project. Our component can be compiled and used in both platforms. This concludes our session. Once again, my name is Bojan Mitov, the president of Mitov Software. You can see my email on the screen. Our website is at www.mitov.com. We offer a number of products for video processing, audio processing, digital signal processing, computer vision, data visualization, visual instrumentation, and artificial intelligence. We also support a number of open source libraries, including the OpenWire library available at www.openwire.org and the Delphi-friendly GDI Plus library called iGDI Plus available at www.igdiplus.org. We also have 25% discount coupon available to the participants of CodeRage 6, which will be available until the 25th this month. Thank you for listening, and now it's time for questions and answers.